Hi, and welcome back to AWS Julie. Today we're continuing our new series covering network fundamentals in AWS, and we will cover network topologies and design. And coming up, we're going to also talk about the AWS Well Architected Framework along with the shared responsibility model. Please remember to share this video with anyone who may be interested. Give it a thumbs up if you like it, sub if you love it, and let's dive in. So from the OSI model, we are trying to dive into network topologies and talk about how we design our networks. When you're designing a building or troubleshooting your network, you're going to most likely be using a topology type. So this is our LAN design that we ended off with in our OSI model videos. And this is a hub and spoke design, which we're going to talk about more in just a minute. But in your design, you need to be able to see the way the data is flowing, so you know the flow of traffic between points in your network. And we covered the hub and spoke topology in our OSI lessons, where the network hub is in the middle and the spokes are our devices on the outside, and all devices are connected back to the central hub. This type of design is used in most large networks, but in small networks too. You may also see a ring design, and these ring networks usually have additional rings for added redundancy, and they are also used in metropolitan area networks or MANs. However, if a connection is severed, then this ring may not be able to send data through the ring, but will traverse back as far as it can, so it's going to loop back. And in early local networks, a coaxial cable was used to create a bus network. But it's important to know that this is a single cable, and with one break in the cable, your link is going to be disabled. Another topology that we see a lot today is the mesh, which is multiple links to the same place so that you have a fully connected but also partially connected network. This design adds redundancy because there are multiple connections, and it's great for load balancing networking, adding fault tolerance, and it's also used in wide area networks or WANs. Now you can also combine topologies together and create a hybrid network design too, and there are also wireless topologies that connect devices through an access point. IoT designs for your network use a mesh network with ad hoc topologies. Let's also dive into network types because we need to know and understand the requirements in order to build the best design for our network. Up first, we have peer-to-peer networks, which allows everyone on the network to talk to everyone, and everything runs on everyone's system. This adds a lot of overhead management, and it is also hard to secure. There's also the client and server designs. And in this design, clients talk to the server and do not communicate with each other. This can add performance, but you have to maintain this server, and it can be expensive because you need a server, you need the software, and you need a place to store it along with storage. And we've already talked about our local area network or LAN. So this is our home network, but it can also be a group of building, and this adds high-speed connectivity. MAN is a metropolitan area network, which we already mentioned. It's usually a city-wide area, and often this is used by governments. Outside of MAN is WAN, which can span the globe. So it's global, like the AWS Global Network, and this connects many individual local area network connections. And then, of course, we have the wireless networks, which can be used between buildings. And it is important to know that this is limited to a certain geographical area, but that distance can be extended with many other access points. And then we have our personal area networks. And so this is Bluetooth. Bluetooth uses a personal area network or PAN. And this is used usually in your own private network. So in your car, connecting to your wireless headsets and so on. And then between LAN in a building to a MAN, we can use a campus area network. And this design is used for a lot of universities. Now let's dive into how users access data from our network design. And up first, we have our network attached storage or NAS. In this design, you connect to a shared storage device across the entire network, and this is usually kept in a data center, and it provides file level access. And in AWS, this is going to be EFS, the Elastic File System, or FSX. There's also SAN or Storage Area Network that adds block level access, and in AWS, this is the Amazon Elastic Block Store or EBS. And for both of these, you need an isolated network, but also high speed. Now, how do we ensure our communication across our network that we just designed? One option is multi-protocol label switching or MPLS. And this allows us to transport any type of data using any type of protocol. So remember, with IP protocol routing, you have to consider the hops and the subnets used, as we learned in our earlier videos. But MPLS focuses on labels that are pushed onto packets, and then those labels are removed as the packet leaves and reaches the other side. Inside MPLS, you have to create an initial configuration, letting us know where all the sites are located and the labels that can be used. And this is the multi-point generic router encapsulation. And then we also have our software-defined networks for WAN, for our wide area network. And in AWS, this helps your network understand where that data needs to go. These days, we do not just use a data center in one building. We can use the cloud. Specifically here, we're talking about AWS. And this design allows the network to understand and communicate directly with the resources in AWS, and our traffic does not have to traverse through our data center. And this software-defined WAN knows where to send data based on that type of data. And in AWS, we have the AWS Cloud WAN, which is a great service for this. Now I'm going to end this video here and continue on in our next lesson talking about designs and cover the AWS Well Architected Framework and the shared responsibility model. Thanks so much for stopping by, and I hope to see y'all again real soon.